All right, now we're going to look at 5.4, which is on page 11 in your notes. We're looking at proving triangles congruent using two other theorems, ASA and AAS. And we usually just call them angle side angle and angle angle side. So let's look at this one. Now we're going to talk about using an included side. So an included side is the side of the triangle between two angles. So if we're going to look at that, that would look like a triangle like this. And then if we were looking at maybe this angle up here and this angle down here, the included side would be right here. And this would be an example of angle, side, angle. There we go. Angle, side, angle, congruent. So if we had two triangles exactly like this, oh, sorry, paste, copy, paste, there we go. Two exact copies, we would have angle, side, angle congruence, okay? Now, here's an example of angle, side, angle. We have triangle. They tell us that BAC and DEC, so BAC and DEC are congruent, and they've marked them with congruent lines. And they tell us that BD bisects AE. Now you have to pay attention carefully to what bisects what. This one is bisecting this one. So the one that gets cut in half, remember bisect means cut in half, is AE. So we're going to go ahead and mark AE as being cut in half. So now notice on there we've got an angle on each side and a side on each side. So we're really close to that angle, side, angle. We can only prove congruence with 3 pieces of information. So we need one other piece of information, and we kind of have to go looking for it. And in this guy, our last piece of information, hopefully you can already see it, but it's vertical angles. When these guys cross each other, we get those vertical angles right down there. I'm going to go ahead and get rid of that. Now we have our last set of angles. I'm going to mark it right here. So now we've got angle, side, angle. Notice I have not started my proof. I've not started to write it out at all. I only looked at the diagram and I looked at my given information and I found how the two triangles are congruent. And now I have proven that ACB, triangle ACB, is congruent to triangle ECD by angle, side, angle. By angle, side, angle, right there, okay? Now, let's look at the proof and see how it's written out. And I'm going to quick grab my diagrams that I've got it nearby. And it's probably not going to let me move it unless I have all that off there. Bummer. Paste. Put it here. And I'm going to remark all that. So I've got these and these. Okay. So we put in the two givens that our angles are congruent and that BD bisects AE. Now remember, just like when we were doing our side, side, side and our side, angle, side proofs in 5.3, I went up here and I marked out the pieces that we had. So this line 1, that is an angle. That's the information we've got there. And in 2, it's tempting to say that those are sides that we did, but actually no, we don't have a congruent statement in line 2, so that is not information about a side yet. So we can't do that. We have to very explicitly write out that those sides are equal because of that information. So that's what we're doing in line 3. We're saying because BD bisects AE, we know this information. You have to write it specifically. So AC is going to be congruent to EC because of the definition of segment bisector. Remember how we talked about whenever you've got a word in your given, we need to use the definition There it is, definition of, and we need to say which kind of bisector, and we're bisecting a segment, so it's a segment bisector. Okay, so that is our side, and then we need to tell about the angle in the middle. Angle ACB is congruent to ECD, and we could have written this one as like angle DCE instead. We could have written this one as angle BCA. Remember, those angles can be written either direction. It's not going to cause a problem. Okay, and that is our last angle. Now we've got angle side angle, so we are ready to write our prove. So we can send this part to proof and write angle side angle. So that's a full proof. We're good to go. So, can vertical angles theorem always be used to prove angles congruent in any two triangles? Well, not in any two triangles. They have to cross over, right? And then form triangles. Okay. Now here's another proof. You're going to go ahead and try this. So go ahead and pause me and fill in those blanks and then unpause me and check. Okay. Here was those fill in the blanks, and let's go check it out. And I'm going to, wait a second, sorry. I'm going to grab this, that I've got this down here, copy, and let you look at the answers while I paste this. Okay, so here's all the answers, and we've got WX parallel to YZ because of given, and WZ parallel to XY because of given. And then, because of parallel lines, we're able to get some alternate interior angles because this guy right here is a transversal, okay? So if you can imagine, hopefully you found this, but if you've got this set of parallel lines with this transversal, that would mean that these, oh, sorry, don't want to be in highlighter, these angles are now congruent. And then if you're looking at these lines with this transversal, you've now got these angles congruent by alternate interior angles. There we go. So we got those sets of alternate interiors. And then finally, that reflexive is going to be that ZX in the middle. And that's your angle side angle. All right. Next, production. A company that manufactures windows needs to determine the amount of glass required to make the hexagonal window shown. PQ is parallel to TS, so I'm going to go mark that on my diagram. R is the midpoint of PT, so if it's the midpoint, that means it's cut it in half, so let's go mark PR and RT. And ST is 12 inches long, so I'm going to go write 12 inches down there. Okay. Determine whether PRQ, triangle PRQ, is congruent to triangle TRS. Okay. And find the area of the window. So what do we know? You know what? Sometimes when it's in a picture like this, they wrote it out as a paragraph proof down below. And they're going to walk you through this, but what I would do if I was doing this, especially if it's in a picture, I would probably draw it out separately from the picture. There we go. There we go. And I would show what I know. This is 12. These are parallel. And remember, if those are parallel, we get our alternate interiors. Like that. Yep. We also get our vertical angles in here. So we know all of the angles are the same, are all congruent. We do have angle, side, angle, angle, side, angle. There we go. So we can determine that they are angle, side, angle, congruent. So we did determine it. and we can find the area of the window, which they're going to do in part B. So let's go fill in some blanks. Because PQ is parallel, RPQ is congruent to RTS. That's your first fill in the blank by alternate interior angles theorem. Because point R is the midpoint of PT, then TR is congruent to PR by the midpoint theorem. Yep. And TRS and PRQ are vertical angles. Yep. So they are congruent by vertical angles theorem, and therefore by ASA, the triangles are congruent. So there's our fill in the blanks. And then we're going to find the area of the window, and they've given us all that math there. They showed us, 1/2 base times height for a triangle. We know the base is 12 inches, and they gave us that the height is 10.39 inches, so they are giving us a total area of 62.34 times 6, because there's 6 triangles, so about 374 square inches. Okay, now this one, go ahead and try and figure out how many feet of electrical wire is needed to hang lights across the scaffolding, essentially from L to N. Go ahead and pause me. Okay, did you find that it was about 8 feet? Because this one was about 4, so if you're going to double it, you're going to get to about 8. Okay, now we're going to go into angle side. So angle side is when you have 2 angles and a non-included side. So this is built off of angle side angle. It's the knowledge that if you have 2 angles that are the same size, then the third one will also be congruent, because they always add to 180. So the third one has to be congruent as well. And if the third one's congruent and the non-included side was equal, then you still have angle side angle. Does that make sense? So if we have, there we go. Let's see if I can do that. Copy, paste. There we go. And I'm going to grab this. So we've got angle and another one, angle and another one, and a non-included side. That's angle side. But we know that this one must be the same size as this one. There's your angle side angle, our other proof. But instead of going through the whole hassle of proving that that third angle is equal to each other, we just decided that we could just call this angle side, and it's a good proof too. So angle side. All right. If 2 angles and the non-included side are congruent to the corresponding 2 angles and non-included side, then the 2 triangles are congruent. Okay, so let's see one of these as a proof. So if angle L is congruent to angle Q, and angle M is congruent to angle R, and MN is congruent to RS, prove that they are congruent. And what that would look like? Very straightforward proof. We would write them all in as givens, and then we would write the prove out as angle side. Because they've already drawn it in for us. Look at that. The angle, oh, I should be in highlight here. These ones are equal. These ones are equal. These ones are equal. Therefore, angle side. So 1, 2, 3, 4 congruent statements. Angle side. We have our angle side. Check. Good to go. That one's a very easy proof. Okay. This one, a little bit more difficult. Oh, good. I did make a copy of it down below. Okay, so let's think through this one. RQ is congruent to ST, so they marked that for us right there. And RQ is parallel to ST. Prove that the triangles are congruent. Okay, so if they are parallel, then that means that when they're cut by a transversal, we're going to start seeing alternate interior angles, right? And then you could do the other alternate interior one right here. We could. And then we would actually have angle, side angle. But what they want you to do is the easier one. Vertical angles are always nice and easy, right? Okay. So that is where we're headed down here. We're going to do vertical angles with RUQ and TUS. And then we're going to do URQ is congruent to UTS by the if lines are parallel, then alternate interior angles are congruent. We got side, angle, angle, and then that gives us our angle, angle, side. Go ahead and write her down. You can pause me if you need a little bit more time. I'm going to scroll a bit further here. All right, go ahead and try this one. DAC is, and this one's tricky because this is overlapping triangles, okay? We've got ACD is congruent to ECB, okay? And what I want you to see, and why I like highlighting it like this, is because you see that this angle is the same angle. In fact, I really recommend when you see overlapping triangles like this that you draw them out individually. Oh, goodness, that was terrible. That's terrible too, but hey, it came out better than the last one. Okay, and then okay, and that you write them out. C, E, A, D. Wait, did I write this wrong? Yep, I wrote that wrong. This is supposed to be B. B, C. And that you write out what's equal. So DAC, BEC are equal. Then they tell us that DC is equal to BC, okay? And then you notice that this is equal also, okay? Draw them separately. That's my hint. All right, go ahead and pause me, write out your proof. All right, and did you get those answers? I hope so. All right, if you need anything else, come and let us know.